Good afternoon. Okay, this research, we are just evaluating the varieties and comparing them. So our topic was influence of nitrogen supply on photosynthesis, chlorophyll content, and yield of improved upland rice varieties in Western Kenya. I'm from Maseno University, and my collaborators were from KALRO, that is Kenya Agricultural Livestock Research Organization, and East Africa Plant Productivity Product. So that's going to be my outline of presentation. So as a way of introduction, you find that in Kenya we have got low production of rice, which is estimated at 126,399 tons, against consumption of 540 tons per year. So the deficit is normally met by importation of rice from Pakistan, Thailand, and India, and the Asian countries. And this one is impacting negatively on the country's economic growth. And we find that we hear of hunger and starvation in the country in most times of the year. So we are really trying to improve our rice production. So part of the reason as to why we have got low domestic production has been attributed to low soil fertility, which is prevalent in the farmers' field. So most farmers are not able, most rice farmers are smallholder farmers, and they're not able to supplement what is lacking in the soil by buying the inorganic fertilizer, since we have got high fertilizer prices and they're not able to afford them. So we have got the Mwea upland rice varieties that were bred by KALRO. KALRO is a national organization, agricultural organization, under low nitrogen management. And we have also the Nerica rice varieties, the new rice for Africa, that have been shown by some authors to give high yield under low input condition. So we find that nitrogen is very important for plant growth, as it's a component of chlorophyll, the enzymes, the hormones, and it's also required by rice at very critical stages, especially at mid-tillering for cell elongation and cell division. Also, we need it at panicle initiation and also at grain filling. So the problem statement was that we have got resource-poor farmers who are faced with two main challenges. On one side, they have got the low soil fertility, and on the other side, they have the escalating fertilizer prices, which has led to low yields and starvation. And we really need to improve our production. So the objective of the study was to investigate the effects of different rates of nitrogen fertilizer on total chlorophyll content, photosynthetic rate, and yield components of improved upland rice varieties, and to compare the performance of my upland rice varieties with the Nerica varieties. So the research hypothesis was that nitrogen fertilizer is very important for biochemical and yield component of rice, and at optimum nitrogen, we find that yield is fully expressed. Above and below the optimum, yield is inhibited. But the Nerica rice varieties are responsive to nitrogen, and we hypothesized that the Mwea varieties are not responsive to increasing nitrogen rates as the Nericas, and the Mwea varieties are not adapted to low nitrogen input. The study materials we had Nerica 1, 4, 10, and 11 that have been released to farmers in Kenya, and we had the Mwea upland rice lines 1, 2, 3, and 4 that were bred by KALRO under low nitrogen management. And the treatments were nitrogen rates 0, 40, 80, and 120 kgs per hectare, applied as urea in 2 equal splits, that is 14 days after sowing, and also at panicle initiation, that was after 42 days after sowing. Then this plate here was taken during data collection. This also during data collection. The experiment was conducted in Western Kenya, And then we had soil chemical analysis to ascertain the chemical component of the soil before starting the measurements. The experimental design was split plot factorial in a randomized complete block design, whereby the main plot consisted of nitrogen levels, and then we had the 4 nitrogen levels, and then we had the subplots being the varieties. So this plate here was taken during the sowing, and this one during data collection. So data was collected on total chlorophyll using SPAD that was done non-destructively at 72 on the 72 plants per treatment, and we did estimate at 28 days, 42 days, 56 days, and 72 days. So these days were chosen because 28 days we have got the active tillering of rice, 42 we have got mainly panicle initiation, then 56 the heading, and then 72 the milk stage. Then we also had the net photosynthesis, which was determined using a portable infrared gas analyzer. This was also done at day 28, 42, 56, and 72. Measurements were mainly taken in the morning hours up to 1300 hours. Panicle length was determined at physiological maturity using meter rule, whereby 5 hills were sampled from each plot. So at physiological maturity, 1 square meter of the plots were harvested. Then the paddy was dipped into water. And then we had to separate the empty grain from the fill grains. So here we had the empty grains, and here we had the fill grains, which were used to calculate the fill grain ratio percentage according to MOA 2011. And then yield components were also calculated from that according to MOA 2011. Here we have got the rice moisture tester that was used to determine the moisture content of rice, of the paddy at harvesting. So we analyzed our data using SAS, and then we did the linear regression. So we found that total chlorophyll increased with increase in nitrogen content, and the Nericas and Moa varieties had significant differences in that at low nitrogen level, that is at 0 and at 40, the Moa varieties performed better than the Nericas. But when you come to higher nitrogen content, that is at 80 and 120, here we have got the Nerica varieties doing better than the Moa upland rice varieties. Moa 1, so at treatment 0, where the control where we didn't have any nitrogen application, Moa 1, so this is Moa 1 and 2, had significantly higher total chlorophyll as compared to the other varieties. And then at 80 and 120 nitrogen, there was no significant varietal difference. So we find that nitrogen is a component of chlorophyll, and for that reason, the the chlorophyll content reduced with the reduction in nitrogen content. So net photosynthesis also followed the same trend, whereby Moa 1 had significant higher net photosynthetic rate at 0 and at 40 as compared to Moa 3 and 4 and the Nerica varieties, while Nerica 4 had higher net photosynthetic rate at low N. So here we have Nerica 4 having net photosynthetic rate as compared to these other Nerica varieties. So low N, low photosynthetic rate was attributed to low nitrogen because we find that nitrogen being a component of chlorophyll, so when we have got less chlorophyll, then photosynthetic rate will be affected. So the panicle length also increased with increase in nitrogen content. And plants at 0N had the shortest panicle length. Moya 1 had significantly higher panicle length at 0 as compared to the nericas, these ones here, and Moya 3 and 4. And then Nerica 4 recorded significantly higher panicle length at 0. So here we have one Nerica 4 as compared to the other 3 Nerica varieties. The field grain ratio percentage also increased with increase in nitrogen content, whereby Moya 1 and 2 had higher field grain ratio percentage. So here we have our Moya 1 and 2. So at 40 also we have our Moya 1 and 2 having higher as compared to these other varieties. And then Nerica 4 had significantly higher at 0 and 40. So here we have Nerica 4, and also here we have Nerica 4 having significantly higher field grain ratio percentage as compared to the other Nerica varieties. And then so it was assumed that the nitrogen enhanced photosynthetic activity during grain filling, and that's why we had higher field grain ratio percentage with increase in nitrogen content. So yield component also followed the same trend, increase in nitrogen content, and Moya 1 had higher yield components at 0. So here we have Moya 1. Here also we had Moya 1 at 0 and 40 N, while Nerica 4 had greatest yield at all levels as compared to, so here we have our Nerica 4. Here also we have our Nerica 4 as compared to those other varieties. So it was assumed that high total chlorophyll and higher photosynthetic rates led to high yields in the varieties. So this was also attributed to better nutrition, which helped in the partitioning of the assimilates. So in conclusion, we say that the Moya upland rice varieties performed better at low nitrogen level, while the Nerica performed better at high nitrogen level, because we saw that when nitrogen was not limiting, then the Nerica varieties were performing better than the Moya upland rice varieties. We also noted that Nerica 4 was better at low and at high nitrogen levels. So we say that Moya 1 and 2 and Nerica 4 may be more tolerant to low nitrogen, but still these were preliminary studies, so the experiment is still undergoing to determine the optimal level for the varieties. So acknowledgement, we thank God for the help to undertake the study, and we have got the East Africa Plant Productivity Product who sponsored the study, then the CALRO that are collaborators, then we have the African Women Agricultural Research and Development that sponsored my coming, and Masai University for giving me the time to be here, and the audience for listening. Thank you.